Hello friends, again a new video for explain the new tools that we have incorporated RecMin Professional. In this case it's about the design tools, underground infrastructure, galleries, wells, chimneys, and taking into account the potential that the professional has, that is, all 3D. Starting from that, we can define in 3D the route that we would like do. For example, let's start drawing what could be a ramp of access to exploit that mineral body we see there. We make a lace at the initial point. It would be the surface. Where do we want to start the gallery? And another lace at the end point where we want the ramp to end. The solo will use start point and end point. Remember that when we are drawing 3D lines, we have managed to draw on the plane perpendicular to our site, and in the lace we'll place the corresponding coordinates. Then on this side we select and tell him we want to draw this design, make this design. Well, we have something very similar that we have in the free, but simpler and with more potential. We can define the typical sections, both circular, rectangular, shape of gallery, giving the corresponding parameters of height, wide, and also at what height. The axis, the turning radius of the corners, very important where it goes to. Be the axis respect of the soil to be able to fit it to other galleries. Another structure, and also in positions, type that we have drawn or draw, taking into account that you will only use the X and the E for the line. And there we have the 0 of that section that we draw. We save it in an RNX file. To use is going to be a shaft position. Well, we have the option that we generate, also apart from what is going to generate. Let's see, again in the event that we go to Advanced Design, to the options, Advanced. If we go to the Design of Advanced Options, we are going to have the option that the same tester calculates the turning radius. And I put the areas that we consider as maximums. In this case, we have started with maximum slopes, without taking into account the starting point and final point. As a slope, it's very big, you cannot go directly, you have to put some spiral loops to be able get to the level. Well, it came out a little wrong. What we do is modify it. Let's change, give it a little more travel, separating a little the turning areas that we have gotten. The two vertices, we need the polyline. We move to the position that we consider opportune. To have in mind that you will only use the position of XY, the bound only will use the height of start, end level or 2. What are we doing now is the advantage. What do you have now? No. The only thing we say here is where we want him to make the turns. We activate again, we change a little the radius of the turn so that it is not so strong. We have separated it a little and we see, as it would be in this design, he automatically sees that we have to put loops, maybe a bit exaggerated, right? We want to go down a lot of slope suddenly, right? But nothing else to do, something like that. But hey, it's good as an example so you can see how it works. This is the general scheme of how it works. But let's see all the options there are. I'm going to draw here in this example, or simply something simple, starting from a starting point that fit. You can get to it to another end point. I fit there in that body, more or less in the same place, and it's more or less what I did, right? Have noticed what we have said, starting point, and the end point is what you are going to use. We tell him again to do during the application, and here what let's do is just do not enter the advanced options. If I put the advanced options, I'm going to look for turning radios and nothing. It's just going to unite with those kinds of sections, and it happens that when we have curves or changes of very strong direction is going to us draw, or it will look very bad. Apart that it is not logical if the curvatures are small, because it would be enough. The first option is not valid for chimneys and things of these. We stop at a starting point, and do not we. Now we go the advanced options. We put the uniform slope to place A and use starting end with uniform slope, taking in the counts the maximum and straight slopes in curves that we have gotten to get from that initial point at the end. It is that route that we see there. We see that a new axis has not been drawn. We can already, if it is what we want, we can save the initial, the axis and the route that has drawn us. And he has drawn us that meshing. Now let's try using only point of start and with maximum slopes. With this point I start with the maximum possible slope. Where would it go? You see that I could only get there. I have changed a color to distinguish it. That green color would tell us with that travel to where we can go down of elevation, taking into account that we cannot spend more than 50 earrings. What are those considered transit? In this case, we have put 12% in curves and 15% the rest. Let's try now but with slopes. Minimum, noting this point is the starting point, nothing more. With slope minimum, I will give another color. With slope minimum would arrive there. Why minimum slope? It is 2%. It's very normal that in underground mining, in the crossing of both is a minimum slope. Why? Because the water has to run with little. Pending begins to give many problems of the galleries, because they are material, very compact and bumpy and everything, right? Always convenient on a slope to enter or even 4%. Now we have done the same, but we have fixed the end point. If I want to get to this point with the slope maximum, where should I start? It would be that gray, right? Let's do it right now, but telling him that we fix the end point. And also with minimum power, which is from the database. We would have this that we have drawn. Or the concept is this, we will be able to fix starting point or end point, or both, and we're going to be able to tell him to calculate the average necessary of the slope to arrive. That he distributes it, and if it is not possible because we get to the slope is greater. So tell us what kind of infrastructure we need, spirals, etc., right? And we can fix only one, the start, the final, and in that they work with slopes maximum and minimum, and be able to design a easy way our infrastructure. We have done the same now. On the other hand, I've put a little more tour to match the starting point, a final point there. I can move it and change to the end point, can be the one we want. I'm using lace points of the body. It is normal I have to make a horizontal section of the body and look for the points that be at a distance. Now I am going down a bit and placing that I want to get to more or less at this point. Maybe it has to be separated from the body. That's the least of it. The case is that you understand how is the functionality and how can you design things very easily. Let's say now that you go from that starting point to that end point with uniform slope. As you see, it's still a lot of slope. We want to get very down. We need several spirals to get there, right? We cannot get there so fast at the point. Good. The case is that they are clear about to work on the program and the simplicity that he has now to be able to draw the structure. Well, now let's see how we can add other parts of the underground infrastructure. For example, a gallery. We are left with the axis. Remember that he said that by doing important part open some galleries with others or with walls. The axis was at a height with respect to section. In the type section we place it in one place. In this case it was 2 meters, right? In order to maintain that height so that all functions well, then we see there a gallery more or less horizontal to approach the body. It is a straight line. Could curves also like us? I understand, but in this case simply let's do as a promotion, else you just see section type with 2 lines. We do not need to calculate curves or anything. We can do it directly, but if I want to maintain a minimum slope array, determine slope, we would go to the advanced options. In this case, we use a starting point and final point, and is that travel, that is, we already draw the corresponding gallery. Well, let's now put here by example a niche to launch a pipe or chimney. Ventilation, for example, we draw 2 segments, we make the initial fit, the 2 segments for leave a midpoint lace, I think it sounds easier, fit to the fireplace. And we tell them to draw us there with a minimum slope. That I draw it with plus or minus 2%, and that it's more or less we will depend on where is the end point, is above or below. In this case it is below. Should be better above. Now we go back up the point, end up or power already. We show with some 2 versions that some more are coming out. Simple, I'd better put in the menu that we wanted to go up or down, without having to give the elevation. In this case we are going to raise the final level up. We can do right now. And if I repeat, you see that now he puts it on me, with the +2 but outwards, so that it does not accumulate in that niche, but to get it out. In those drainage points that are, I tell him to fix me half. Minimal slope, I draw it. And you see that now it is up. I put more 2 instead of -2. Let's now remove the one we do not like. Let's leave one of them, it does not have importance for this. Let's put height things we do not like, that bother us, to simply leave the lace stitches. From that axis, let's also leave the surface topography. Let's deactivate that. We activate the topography and we go to look for a point in the level lines, a point from which we want to draw or make the fireplace. Ventilation. If we did not have a point, we would draw one. Let's take one, any of the level lines. We can draw a segment. For example, we got there. We draw this as the axis, we select. We start again the same. Options, we tell you to circulate with 10 sides. For example, better be 10, finally we can even draw sections of 7, no. That is, instead of circles we choose sections. It is not very useful but good. Can be used for other things. Circular type section, it is much simpler. We already have the fireplace drawn. Well, let's imagine now that we want draw a vertical well. Well, let's draw here as reference to a segment or 2 segments. We join 2 level lines to define the height and point in the middle of where we'll start the shaft of the well. Now we select it and we make a copy and paste. If we copy and paste, we know that it sticks same side. We select again one of them and we lowered it 300 meters or meters that we want of depth towards the well. As we copied is that we have there down the segment copy. We have one above and one below. It's exactly the same in XY position, but one is displaced down. For the meters, the 300 meters we have put right. Well, we already have 2 points, located verticals, which are the centers of those 2 lines, which are worth. To draw it, we now draw an axis that goes from the top point to the point. From below, making the lace, we put a view that suits us, so that the other geometry does not bother us. We draw fitting, we click on one below. We click one up and we have another one. Let's repeat it. We select the axis, we do the same. Let's draw a fireplace here. We leave the line edited. Let's put more than 10 meters. For example, on the sides, the axis in the center. Remember, where was the last time? And we need to go towards the advanced generate, and we already have a well drawn. This is completely vertical. We could now continue down with other fatter ones, if we want to do. With more width, we can draw any geometry type now, not just gallery design, but also take into account the power of the program to draw lines, and do it in wireframe, in models from any area. As we saw in other videos, Well, let's see now another example. Let's remove the wire from. So I did not bother, we stayed with the shaft. Let's go from the curve, for example, and do an access to exploit them there. For example, we make a turn, have an account. The lace, we can draw a lace, just give it a third coordinate, we are seeing from below. We turn it, now we are looking from the bottom up, we have that advantage. We can draw in the position that we want, and we will access in this way, from there to the body, from that point, from that bend, and let's give it again to the section. We have to change now the parameters with the dimensions that we are working, and especially the distance from the shaft to the ground. And we are going to fix. In this case, we are going to fix only the start height to fit with the gallery and with maximum slopes. If we want to make that body with slope maximum, to see where we got to see if it is insufficient, we want make more run. It would be another example of design. Good. Finally, just comment that the sections do not have what to be only curves, closed lines. We can put sections in all kinds of channels. These lines can go per surface. It can also be for another type of applications. And if we put a type section open as these examples, but as what we had at the beginning, we put them on these two axes that we already have drawn. No more. I return to hide the T3 axis. We changed it. The section, we say, that generates it. You see that the ramp, what we did was put a kind of slide. Does not matter much for what we are talking about, design of underground structures, but it may be worth explaining. With curvatures and slopes, channels, things of surface. You see that he does it perfectly, and it allows of this arch. See how the surface is really going to be. It's a general idea of how it works. The program, now in this part of the site of underground infrastructure, we can practically testing everything. It gives us the necessary information to know if we can arrive with certain areas, etc. Thanks, and until the next video.